So in this video, we're going to talk about how to describe the domain of rational functions. So remember, we talked about the domain and range, and graphs of rational functions have what are called domain restrictions. We kind of talked about domain restrictions when we were talking about square root functions. So if we look at the graph of this rational function, notice that some x values are not included in the domain. So you can see here, all the x values up to here are included. And then there's kind of like a break in the function, right? Here where it has a vertical asymptote, there's kind of a break in the function, and then it jumps to including all these x values. So notice that in this function, x does not ever equal 2. Notice that the values get closer and closer to x equals 2, but they don't actually ever equal 2. So rational functions have a domain restriction because fractions cannot have a denominator of 0. So notice that in this function, if I had set x equal to 2, I would have 1 over 2 minus 2 plus 5, which give me 1 over 0 plus 5. Okay, so 1 over 0 is undefined, so that's why we have kind of like a break in this function where x equals 2. So to determine the domain restriction of a rational function, what you're going to do is you're going to set the denominator of the function equal to 0. Then you're going to solve for x. Remember that you may need to factor the denominator first in order to be able to solve for x. So let's determine what values are restricted from the domain of f of x equals x squared plus 5x plus 4 over x squared minus 4x minus 12. So what we're going to do is we're going to set the denominator equal to 0. So we're going to say x squared minus 4x minus 12 equals 0, and then we're going to solve for the values of x. So we can do this by factoring this function. So we have negative 12. So we want two factors that equal negative 12. So that means we're going to have a positive and a negative factor since 12 is negative. Since 4 is negative, we're going to make the bigger factor in all of these pairs negative. So we have 1 and 12. So 12 will be negative. 2 and 6, where 2 is negative. And then 3 and 4, where 4 is negative. If we add these factors together, 1 and negative 12 gives us negative 11. 2 and negative 6 gives us negative 4. And 3 and negative 4 gives us negative 1. So 2 and negative 6 is the correct combination of factors. So when we write this out, we're going to have x plus 2 times x minus 6 equals 0. So remember, we can solve this by now setting each factor equal to 0 and then solving for x. So if we have x plus 2 equals 0, we can solve by subtracting 2 from both sides. So we have x equals negative 2. X minus 6 equals 0, we can solve by adding 6 to both sides, which gives us x equals 6. So that means in the domain of this function, x does not equal negative 2, and x does not equal 6. So those are our domain restrictions for this function. So now let's determine what values of x are restricted from the domain of f of x equals 4x squared plus 1 over 9 plus 3x. So once again, we're just going to look at the denominator. Okay, so we're going to say 9 plus 3x equals 0. And so now we're going to solve this equation. Notice that 9 and 3x have a common factor of 3, so I'm going to divide out that factor of 3 from both terms. So when I do that, that leaves me with 3 times 9 over 3, which is 3, plus 3 over 3, which cancels, and then we have x. So I can divide both sides now by 3. So I have 3 plus x equals 0. So if I solve 3 plus x equals 0, which I can do by subtracting 3 from both sides, that gives me x equals negative 3. So that means that in this function, x does not equal negative 3, and that is my domain restriction. So now you can go ahead and pause the video and try this example on your own. So when you do this example, you're going to set the denominator x squared minus 2x minus 15 equal to 0. So when you do that, you will find that you can factor it by finding the two factors of negative 15 that add up to negative 2. So that combination will be 3 and negative 5, so we have x plus 3 times x minus 5 equals 0. So that gives us the two values, x equals negative 3 and x equals 5. So those two values will be restricted from the domain of this function. So in summary, since you cannot have a 0 in the denominator of a fraction, some values are restricted from the domain of rational functions. You can find these values by setting the denominator equal to 0 and then solving for x. Remember that you may need to factor the polynomial in order to solve.